So we have learned how to find the intersection for a line and a plane, and in this lesson we are going to see the intersections of two planes. Here are the three possibilities for the two planes intersections. So the first one is the two planes intersect and along a line. And the second one is parallel, so no solutions, zero solution. And the third one is coincident. They are the same line, so infinite solutions. And this one, although is equation of a line, so it also have infinite points on the line for the intersections. So we are going to see, and we are going to use a Cartesian equation for the plane to solve the equation. So the first one, we have two Cartesian equations for each one for a plane, and we are going to use similar ideas that we have used to solve the linear system, so substitution or elimination. So for this one, we may just try the elimination. So see the x, so we want to get rid of one variable, so we want to times the first equation with 2. So each term in the first equation by 2, then we are going to see what we are going to have. So equation 1 times 2, then we have 2x minus 2y plus 2z equals 3 times 2 is 6. So this is our equation 3. Then we want to get rid of some variables, and you will see actually if we don't do the subtraction, if we do the addition, then we could get rid of more variables. That is what we want. So you see 2y negative 2y minus 2z positive 2z. All you could do just subtract those two to get the equation, then it's okay. So, but by adding these two, then we can get rid of y and z. So equation 2 plus equation 3. Then 2x plus 2x is 4x. 0y, 0z equals 3 plus 6 is 9. Then we solve for the x, we move the 4 to other side. We are going to have x equals 9 over 4. So this is the equation for the value for x. Then we want to get rid of the x. So or we could sub this one back to find the yz, but these two subtract will be easier to get rid of the x. So equation 2 subtract equation 3. So 2x minus 2x is gone. 2y minus negative 2y, we have 4y. Negative 2z minus 2z give us negative 4z. Then 3 minus 6 is negative 3. So now we have x equals 9 over 4, 4y minus 4z equals negative 3. Then we know that is r equals r0 plus t times the direction vector. So we want to close to this one. And we want to compare it with x, y, z. So x, y, z is each direction. So x0 plus t d1. So y0 plus t d2. And z equals z0 plus t d3. So we want to write it as x, y, z equals a number constant plus a variable, then times a number. So in order to write it this way, we are going to introduce a parameter. So we could write z equals t. Then we sub in 4y minus 4t equals negative 3. So solve for y. We have 4y equals 4t minus 3. Move the 4 to other side. Then we have y equals 1t minus 3 over 4. Then we put all of them together. We are going to have x equals 9 over 4. Y equals t minus 3 over 4. And z equals t. So t belongs all the real numbers, and this is our parametric equation for a line. So it means the two planes intersect as one line. And this line is this way. We also could write it as a vector form if you like. So r equals r0 is all the constant. 9 over 4, negative 3 over 4, t here is 0, so it's 0 is a constant. They are the point, then plus t times the number at the front of the t. So this no t is 0, then 1, 1. Then it's done. This is a vector equation. This is a parametric equation. So this is how we solve for the intersection of two planes. So you could introduce z equals t at the very end, or you could introduce at the first started. So, but I highly encourage you to solve for one of it, then let z equals another variable equals t, because if we let x equals t, then it doesn't work out. So try to simplify it a little bit, then introduce a variable that we know is not going to be a constant with a parameter, okay? And the second one, equation 1, equation 2. So again, we are going to see we want to get rid of some of the variables, so we could times 4 to each of the term in the first equation, then we subtract, we can get off the x. Once we get rid of x, we could let z equals t, solve for y, then go from there. So equation 1 times 4, then we have 4x plus 8y minus 12z equals negative 4. Then you will see equation 2 and 3, they are almost the same. So equation 2, they are same. Equation 2 minus equation 3, all of them, left side cancel out, right side cancel out. So this is always true. What it means, x, y, z could be any numbers. They are the same plane, so it's case 3. So therefore, the two planes are coincident. The two planes are coincident. They are the same planes, so you have infinite numbers of points intersect. And this is the last one. So x same, so we could just do the equation 1, take away equation 2, minus equation 2, then all the left side cancel out. The right side 4 minus 5 give us negative 1. This one is impossible. So what it means, we don't have any solutions, no intersections of the two planes. Only one case will explain it. It means the two planes are parallel. Also, you can see it from the normal. So this one, the A, B, C are the normal. This is N1. And N2, you will see is same. The two normal same means the two planes either parallel all constant. So that is what you can see from the normal. Okay, so this is intersections of two planes. And see from here is a little bit tricky, and we are going to learn a new method to solve for the intersections of two planes. We call it Gauss-Jordan elimination method. So multiply an equation by a non-zero constant, then also we could interchange the equations. We could add a non-zero multiply a equation, add to another equation. So all these operations we could use. It won't change the solutions for the system. So our goal is change it to this way. So this is x, 0, y, this is z equals a number. This is y plus a z equals a number. And we let z equals t, then we have the equation, the parametric equations for the line. So this is what we want to do. So we want to change the equations to the 1, 0 numbers, 0, 1 numbers. And so it asks us to repeat this question 1a, okay, the first one. So we are going to copy this to symmetric equation. So just get the number at front, and we want it to align very well. So 2, 2, 2, the number at front of the xyz. Then this is a constant at the right side, okay? So this is our two equations. So this is corresponding to x minus y plus 1z equals 3. And this corresponding to x plus 2y minus 2z equals 3. So they are the two equations. And we want to convert these two equations into this in the metric system. And these two operations we could use. We could times a number to each row. Each row represents one equation. We can interchange the whole equation, this one to the first one, this one to the second row. And also we could add a number that times it, then add it to another one row. Each row represents one equation. So now the first one is 1 already. It's good. We want to change this one to 0. So we call this one is our row 1, row 2. Okay. So how to change the second one to be 0? We could do it is equals R2 minus 2 times R1. So we want to do is R2 minus 2 times R1. The reason why we want to do this, then this one will be 0. We'll match this here. So we copy the first row. We don't change the first row. We just change the second row. This minus 2 times the first row. 2 times 1 minus 2 is 0. So all we could write the whole steps here. So it's 2 minus 2 times 1. That is for the first column. The second one, 2 minus 2 times first row. This one, negative 2 minus 2 times 1. The last one, 3 minus 2 times 3. So this is here. Then we simplify it. We are going to have 1, negative 1, 1, 3. Then first one is 0. The second one is 2 minus negative 2 times negative 1 give us 4. Negative 2 minus 2 times 1, negative 4. 3 minus 2 times 3 is negative 3. Then we want the second row. This number is 1. So what we want to do is The next step equals, we copy the first row here. The second row, we want to divide by 4. Then 0, 1, -1, -3 or 4. So compared to the finals, this one need to be 0. So this one is 0 already. We could just plus this one to the top. Then we could get this 0. So this one, the second one don't change, but the first one going to plus the second row. So we copy the second row here, and the first one plus the first row plus second row. 1 times 1 plus 0. This one -1 plus 1. 1 plus, 1 plus -1. Then 3 plus -3 over 4. Simplify it. We are going to get close to the form 1001. And just calculate for those numbers. So this is 0, this is -1, -3 over 4, then this one is 9 over 4. Then this 9 over 4 is from 3 plus -3 over 4. Change it to same denominator by times 4 to both numerator and the denominator. Once we have the same denominator, we are going to add or subtract the numerator. So we have 9. That is what. And this is our solution. So how to write this out? We are going to write this is x plus 0y 0z. So for the equation of the line, we just let z equals t. So x, y, z, introduce one variable. Z equals t. X is plus 0y plus 0t equals 9 over 4. And y, 0x plus y, so this one. This is y minus z equals -3 over 4. Then we move the z to other side and sub in the z equals t. We have t minus 3 over 4. So compare it with our solutions for the first method. You have 9 over 4, t minus 3 over 4, t. So compare it. This one, yes, t. X equals this one, y equals t minus 3 over 4, and z equals t. T belongs all real numbers. So I don't mind you pick this method or you pick this elimination method, but I highly encourage you to do the second one, because the next lesson will be the intersection of 3 planes. For the 3 planes, we are going to use this matrix method, the Gauss-Jordan elimination method. So what we have done is we get all the numbers at front of the equation, Cartesian equation for a plane in the matrix. Then we try to keep the 1 for the first term. Then use this 1 times a number, subtract to get all the other numbers in the first column 0. Then after that, we want to change the second row, second number to be 1 by divided a number. Once this one is 1, we could combine it with the first row to get the second number in the first row to be 0. Then we have 1001 at this form. Then we let z equals t. Then we can write the equation of the line. And also, I will introduce how we call each number. So this one we call it A11 first row, first column, and this one A12 first row second column, this one first row third column, first row fourth column, and do the same thing, second row first column, second row second column, second row third column, second row fourth column. So first number is row, this is a number of row, and the second number is a number of column. Then it will be easier for us to talk about which number. Just say, okay, A11, A12, A13, A14, which number, instead of say 1, then we don't know which one is you are referred to, okay? And this is for this method. Then we are going to continue practice more. So it asks you to determine the solution of the following system of equations. So 2x minus y plus 3z equals negative 2. 2x minus y minus 3z equals 1 using Gauss-Jordan elimination method. So we are going to copy these two equations here. So 2x minus y plus 3z equals negative 2. We write it in this form. Then we take the a, b, c out. So this one is just, we could write it as d, but h actually is negative d. But anyway, we write it in this way. Then we convert it to the matrix. Okay, so we just keep the numbers at front of x, y, z, and also the constant on the right side down, right down here, negative 3, 1. So this is R1, R2. Then we want to get the second one 0. We could subtract. So R2 minus R1. We are going to have 0, 0. So copy the first row. So 0, 0, this one minus R2 minus 8, we have negative 6. 1 minus negative 2, we have positive 3. So this is this way. Then after that, we are going to see. So then we could write it in this way is we could continue to solve this one. So this one we want to change it to 1. Then what we could do is divide it by negative 6. So we have R2 divided by negative 6. Then we have 2. The first row we don't change, we copy it down. The second one divided by negative 6. 0 divided by anything is still 0. Negative 6 divided by negative 6 is 1. 3 divided by negative 6 is negative 1 over 2. Then we could continue to, this is not the second one is 1, but the third one is 1. So we could get rid of this. So all they are easily. So we could write it as 2x minus y plus 3z equals negative 2. And another equation is just z equals negative 1 over 2. So from these two, we are going to see we are not able to write z equals t because z is a constant now. So we write y equals t. Then we sub. So sub y equals t, z equals negative 1 over 2 into this equation 1. We are going to have 2x minus t plus 3 times negative 1 over 2 equals negative 2. Then we isolate x. We move everything to other side. At 2x equals positive t minus 2. This one is plus 3 over 2. Then simplify. 2x equals t minus change it to same denominator times 2. So we'll have minus 4 plus 1 is minus 1 over 2. Then bring the 2 to other side. We have x equals t over 2 minus 1 over 2 divided by 2 is quarter. So continue. We could write it this way. X equals t over 2 minus 1 over 4. Y equals t. Z equals negative 1 over 2. So this is the parametric equation for a line. So it means the line, these two planes intersect as a line. And also you could write it as a vector equation. So just all the constant is negative 1 over 2. The second one, no constant, is plus 0. The third one is negative 1 over 2, then plus t times direction vector. So the number at front of the t. This one, 1 over 2 times t. This one, 1 times t. The last one, you don't have t. It means it is 0. So this is either way, okay? Both correct. So t belongs all real numbers. So from here you see, once we have the, if both x, y now here, then the z will be a constant. We solve for that. Then the z is not going to be t. We write y equals t, then solve for x. Then we write it in the parametric equation form. Then we can convert it to the vector form, vector equation form. So this is example 3. Then we are going to continue practice another example. One more example. Determine an equation of a line that passes through a point. So it's more complicated and it's parallel. So it means we are going to find the line of intersection from these two. From there we find the direction vector. Then we combine this with a point to find the final equation of a line. So if parallel, it means these have the same direction vector. So now we want to practice on the Gauss-Jordan elimination method. So this time we just get the numbers from these two equations. So 1 number at front of x, y, z, 2, negative 1, then 6 on the last one. 1, 2, 2, the number at front of x, y, z, then 1. So this is row 1, this is row 2, and we want to keep the first two columns, two rows is 1, 0, 0, 1. Then we have x something, y something. The t is, most of the time we let the z equals t, but if z is a constant, then we let y equals t. So for this one, you will see it's interesting. If R2 minus R1, then we keep this one 0. It means R2 need to minus R1. From here, minus z is 0. 2 minus 2, 0. 2 minus negative 1 is 3. 1 minus 6 is negative 5. Then from here, we are going to get rid of the divided 3 to both sides. For the last row to get 1. So 1, 2, negative 1, 6, 0, 0. Then R2 divided by 3. We are going to have 1. 3 divided by 3, negative 5 over 3. What it means? It means the z equals negative 5 over 3 from our the second row. And again, we are not able to let z equals t. We are going to let y equals t, then sub back to write the first row out. So x plus 2y is 2t, then minus z. We sub in the z, negative 5 over 3, then equals 6. Then from here, we isolate x. X equals negative 2t plus 6 minus 5 over 3. So this one negative negative becomes plus, minus, move to other side becomes minus. So we change it to the same denominator. By multiplying 3 to both top and bottom, we are going to have x equals to negative 2t. Then 3 times 6 is 13 minus 5. 18 minus 5 is 13. So plus 13 over 3. That is our first equation for x. Then for the y, it's just y equals t. Y equals t, z equals negative 5 over 3. So this is our line of intersection, and from this line of intersection we just need the direction vector, the number at front of t. So the first one is negative 2, second one is 1, last one we don't have t, it means it's 0. So we have the direction vector, then also we have the r0 from the given, so it's 5, negative 2, and 3. We are able to write the equation of the line as vector equation is r0 plus t times d, or s times d. It's just perimeter times the d. So we write the equation of the line is r equals sub in 5, negative 2, 3 plus s or any other letters mn is just x belongs all real numbers. Then negative 2, 1, and 0. So this is done. So that is all for today's lesson, and we are going to see what we did here. So today we are going to look for the intersections of two planes. So if you have solutions, because we have 3 variables in 2 equations, so we are going to have one variable is not able to be solved, so we let z or y equals z a parameter, then we express other 2 variables in terms of t, then we have the parametric equation of a line. And if you have infinite number of solutions, it means no variables left. So any variables, any numbers will be true. It means the 2 planes are same. And if left side not equals right side, they are parallel. And also you could see from the normal, they are either same or times the number, they are same. And when we solve it, we want to use a Gauss-Jordan elimination method. So we just take the numbers at front of x, y, z and put the constant to the very end. Then we want to try to find the first 2 rows is 1, 0, 1, 2. First 2 rows, first 2 columns is 1, 0, 0, 1. And how to get the first number is the second column, first number is 0, just times the number. The first row, the first number we want to keep at 1. If not 1, we divided everything by 1. And also if another equation, the first number at front the x is 1, we switch them, we could. So once the first row is 1, we just times the number, then subtract from the second one, then you can get rid of the first row, second column. Then the second number, we could just divide the number to each term to get it to be 1. Once we have the second column, the second row is 1, then we could times the number to get rid of the first row, second column. Then we are going to have 1, 0, 0, 1 form. Then we could, if the z is stayed here, we could let z equals t. Then we just write 1x, 0y, 0y equals this one. Then the second column row is 0x plus 1y, then times this t, then equals that1. Then simplify it. We have x, y, z. That is a parametric equation. So we just practice more. And if that is a constant, we let y equals t. Then we solve for x in terms of t. Then we have x, t, y, t, and that is a constant. And if it asks you that pass through a point and parallel to the line of intersection, we solve for the line. Then from the parametric equation, the number found of t, they are the direction vector. Then combine the R0D to write the equation of the line out. So thanks for watching.